All right, scholars, here we go. Now we're multiplying them together. Remember, when you multiply the coefficients together, and then you multiply the radicals together. So 4 times 5 is 20. Root 2 times root 2 is root 4. But what's the square root of 4? 2. So I get 20 times 2. That leaves me with 40. Okay? Pretty cool, isn't it? All right, now let's do another one. You do this one on your own if we had time in class. All right, we'd be doing this. What's 4 times 3? 12. Times the square root of what's 3 times 4? 12. Is that in simplest radical form? No. So I'm going to rewrite it. I'm going to factor this out, taking out the perfect square number, which is 4. Because 4 times 3 equals what? 12. All right, so that's 12 times 2 times root 3, because I took the square root. Once you take the square root, what disappears? The radical sign is gone. Don't keep it. That's an error that's kept very often. That's 24 root 3. All right. Now, another way you could have done this is actually taking the square root first. You get 4 root 3 times 6, because I knew the square root of 4 is 2, so 2 times 3 is 6. Then you just do the two numbers outside, 24 root 3. Either one works, as you know, you get the same answer. All right, now let's look at the next one. I want to add these together. Before you can add or subtract, you have to simplify the radicals. So what's the square root of 4? 2. So 3 times 2 plus 5. Well, that's 6 plus 5, which equals 11. Not hard. Let's do it a little bit more here. I get 3 root 8 plus 13 times the square root of 32. Guess what? I can simplify both of those. So I know the largest perfect square number that comes out of 38 is 4. So those are my factors. Plus, I can do the same thing with 13 over here. I can do 16 and 2. 16 times 2 is 32. 4 times 2 is 8. Remember, I take perfect square numbers. All right? The square root of 4 is 2. I'm going to stop doing every little step here for you because I'm expecting you to do a lot more of this in your head. The square root of 4 is 2. 2 times 3 is what? 6. That's 6 root 2. The square root of 16 is what? 4. 4 times 13 is 52 root 2. Notice once I take the square root of that, I multiply it to the number out front. Now they have the same radical. It's simplified. I can add my coefficients. That's 58 root 2. You treat your radical kind of like you would a variable. You have to have your like terms. And then we have our next one, the square root of 75 minus 4 root 50. Again, I'm going to simplify each radical because I can't add or subtract them yet. Well, 25 comes out of this first one. Got my 4 here, and I got 25 again. Square root of 25, 5 root 3. Square root of 25 here is still 5. 5 times 4 is 20. What's left is radical 2. That's all your answer. You can't add and subtract anymore because they're not the same. Now, one thing I want to remind you is if you square a square root, the number comes out underneath. Your answer, if you knew that right away, is just 10. Makes life easy. But if not, you have to rewrite it like this and go, oh, yeah, that's the square root of 100. What's the square root of 100? 10. But if you realize if you square a square root, or you square root a square, they're gone. It's kind of cool. Now how about this one? That's the square root of 10 squared. Well, it's the same thing as going to the square root of 100, which is what? 10. Again, I'm squaring the square root there. Boom, gone. Okay, let's go to this one. Now, there's a couple different ways we can do this. One way is you can actually simplify the radicals, the fractions first together. I'm going to do is just going to try to get rid of the square root. So I'm going to go ahead and multiply each by root 6. And you have to do it to the numerator and the denominator because you want to change its looks, not its value, and you're multiplying by the number 1. So it's 5 times the square root of 48 over 6. Now those don't reduce, but this I can simplify more. So that's 5 times the square root of 16 times the square root of 3. 16 times 3 is 48. Notice I pulled out the perfect square number. What's the square root of 16? It should be 4. And for some of you, if you have to go like that and go 4, that's okay. 5 times 4 is 20 root 3 over 6. Should I be able to simplify that anymore? Are these two able to reduce now that they're outside the radical? So it's 10 root 3 over 3. Takes a little bit of time. Let's do this last one here. rationalizing the denominator. Now, I'm going to give you a trick. And I didn't do it on this one, but I want to show you how it works. These can reduce, okay? And actually what happens is if I can do this, the 5 can go in the 10 2 times. That actually eliminates the 5, and it becomes 3 over the square root of 2. Then it's a lot easier to simplify your radical. So it's 3 root 2 over 2, because I'm squaring a square root. There would be your final answer. Hopefully this gives you some guidance when you're doing your homework. There's a lot of problems here. I expect tons of phone calls. If you don't know how to do this, you have to become my best friend, okay? Hope you guys kind of figure this out and we can do a good job.